Hello, today we are with Pascalis, who is our assembly engineer, and we will show to you how to use our RG Raman microscope. RG Raman microscope, as you can see, is quite advanced microscope. And Pascalis, can you please remove the doors, or maybe in the beginning show that we can access the sample from all the sides?
Yes, we can do it from here.
Can easily access the sample from all the sides, and we have advanced translation stages with the motion range 10 by 10 centimeters. And can you please remove the
Yes.
front door and show what's inside? And inside we have a microscopy module with 50x microscope objective and then Lightnovo RG Raman spectrometer. This current spectrometer is 785 nanometers, but we as well have another option, for example, this 532 nanometer spectrometer, and they can be easily swapped by this axis from the top. So Pascalis, could you please assemble everything back?
Yes.
And we'll demonstrate the functionality of the software and the principles of how to measure the samples. So let's start the software. We click on Mirror Spec, shortcut on the desktop. So this software is launching. Let's wait, because our software can control the multitude of different Lightnovo instruments. So here we already loaded a proper preset for the RG microscope. I don't think we need to do it again, but Pascalis, you can show that you can do it from help. If you go to help, and then there is an option set configuration, but we're not doing that, and then you load the proper preset. So let's connect the device. We click on connect at the bottom of the screen. Then you can see here it should load the instrument. I think there is some minor problem with connectivity through the USB port. Check if the device is connected, maybe disconnect and connect again, because the stages were connected. Now everything is fine, and we can see that the device is loaded, COM20 port, the spectrometer serial number 40008, and then the stages, and then also the ambient temperature inside and humidity inside of the unit. So what we'll do next, I think we need to home the stage to make sure that the operation is the proper one. And Pascalis, could you please home? Now we're home, and as you can see, everything is moving to its home position. Reaching the end switch, and then moving to the home position, X, Y, and Z. So with this device, you can do XY mapping, you can do Z scan, and you can do basically collect the cubes of data as well. So we'll show it to you later. So now we'll just start some basic focusing on the sample and spectroscopy, and we'll start with a piece of silicon wafer, and Pascalis will put it in the microscope. We'll show how to focus and how to get basic Raman spectrum. We'll put it on the microscope objective. And now the Z stage is in the lowest position. Now Pascalis will focus on the stage. And we actually have, with the sample, we have two cameras. One camera, it's looking from the side. This is looking from the side, and you can see it over there in the end. Then there is this camera, and another camera is looking through the microscope objective. Please switch the camera. We choose the proper device and file, start camera. Now we have the proper camera, and then it's far away from the device, and then now we have to switch LED controllers as well. LED control, LED is on full power, LED is on top over here, and then we'll focus on the sample. So we have the manipulator tab here, X, Y position and Z position with the X, Y, Z and the Z steps, and then Pascalis with the Z arrows will focus on the sample looking at the visible image. We are moving up. As you can see, we are moving up. Here now we're approaching it. Now we have to be more careful not to crush the objective. And yeah. So now we can maybe increase the step size so it doesn't matter. Now you know what to do. Okay, now we see the light is appearing. Now we'll focus on the sample. Okay, nice. And now we see the surface of silicon wafer with some scratches on it, and then this is typical for silicon. So now what we can do, we can turn the laser on. And as you can see, there is some laser spot. We can focus more properly. Now very small laser spot. And then we already see silicon spectrum. Now what we can do, we can also adjust laser power. So Pascalis, please adjust laser power. Increase it and click on. And we can see a slightly brighter spot at almost 50 milliwatts. And increase power of the signal. Another option we have here is the exposure time. Please change it maybe to 500. 500 on, and then the intensity increased. We can scale it, maybe fit to screen, or how is it called, fit to window. Yeah, now it's already saturated. So 500 is too much. Then now we go probably to how much? To go back to 250. Go back to 250. Laser on, and as you can see now it's not saturated. No. So the device is very sensitive, so already at the exposure is 500 milliseconds. We saturate the sample, and let's maybe measure something. Let's take a spectrum. Let's do repetition count, maybe 10, just to do some averaging. 10, and we click on capture. And let's see what happens. The gray line is the spectrum being captured. Now it turns green, it's captured. And we see the typical Raman spectrum of silicon with the line at around 520 inverse centimeters. So let's probably change the sample and let's go to polystyrene. So Pascalis, please switch the laser off to stay on the safe side. And now, yeah, you can move the stage probably. So move the stage down. Take the sample out with the tweezers. Did you home the stage? Or?
Yes.
Okay. But in principle, it's just okay to move along the Z direction. You can move down, no need to home it every time. We take a piece of polystyrene. Polystyrene is a reference sample for Raman spectroscopy. And actually we calibrate our devices with polystyrene spectrally as one of the steps. Do it according to the standard procedures. And now, okay, now the stage is at the bottom position. Pascalis moves it up to see the surface of the sample. Okay, now we have some light and where's the surface? So let's just turn the sample is transparent, and that's why you see a dark image, not so much reflection from it. But let's see the laser spot. Have the laser spot now. It's not in focus. We have to focus better. Maybe. Yeah, here we are. Here we are. There's some scattering, like this concentric rings, but what matters is the laser spot. That's where you measure. And now we see, can you please do the fit to screen? Here we see a typical spectrum of polystyrene. And let's maybe capture this spectrum again. We do the same, under the same settings, we just do capture. And is it capturing?
Yes. Let's capture again.
But it's not showing plot captured sample. It captured now because we have an option to plot live spectrum, plot captured spectrum, and plot the reference spectrum, which is relevant to mini Raman. But now we're using RG spectrometer. So now it captured, and we see in green it's the captured Raman spectrum of polystyrene.
Hello, I'm Yaroslav, and I'll show you the mapping functionality of our Lightnovo RG Raman microscope.
So we are already in MirrorSpec software here, and Pascalis was doing some measurements on polystyrene, and I'll show the mapping on polystyrene. So what we have to do with the mapping, first we have to go to Raman mapping settings, and we have to make sure that X and Y coordinates axes are loaded. We load all of them, and then we want to do X and Y mapping, obviously, and then here we have X and Y, and we have options: start coordinate, range, counts of steps, and the step size. So first, as we go to this image, visible image, we already want to start with the current spot and as an initial coordinate for the map, and we click on this arrow to load the coordinates, and as you can see, the start coordinates changed to 300 and minus 500. Now let's specify the range. Let's say that we want to do 100 by 100 micrometers scan with the number of steps. Let's say, I don't know, 6 by 6. Let's do a map like that, and then that would mean that the step size is 20 microns. So 100 by 100 microns with a 20 micron step. Then we need to make sure that we choose the proper laser, 785 nanometer laser, units in wave numbers. Then we have an option turn the laser off. We also have an option of zigzag scan if necessary, but let's just do normal scan to start with. Then we have to specify the file name, which would be polystyrene. Polystyrene, and then we can start the scan. So now the scan started. Go to Raman mapping viewer, and as you can see here, there is a progress of the scan. So now it's 13%, and let's go to Raman mapping viewer. We have to choose here's Raman mapping viewer. Have to choose the proper coordinates. It should be, I believe, X, Y, wave number, and we choose the wave number, which would be, let's say, 1000, and with half width, let's say 20. And it would be showing the intensity, as you can see, of this 1000 polystyrene peak as a map. And we can switch to other wavelengths wave numbers to map them, and then you have all the information in the data file, and later on you can process with the data analyzer. That's all what we wanted to show. Thank you for your attention.